Good day, viewers. I welcome you all to another maths lesson designed for senior secondary school level. The topic today is graphing quadratic functions. So we'll look at the quadratic functions, and then we'll look at how to draw the graph of the quadratic functions. One thing that I will emphasize here is there is no single way of solving a quadratic function. The method that you might be taught at school level and this method might differ. But the most important thing is at the end, the solution that I'll get here and the solution that your teacher might get should be the same. So that is very important. Follow, you'll understand, and I'll explain all the steps involved in solving quadratic functions. Then you compare with what you've covered. If there's any difference, they're all good methods. So whichever method that you use, but try and understand this method because it's very important. Graphed by following 5 steps. To graph a quadratic function, we are going to follow these 5 steps. So step 1, first we have to find the axis of symmetry. It's very important. And step 2, we're going to solve how to find the vertex of a quadratic function. Step 3, we are going to solve for y-intercept, to identify the y-intercept. Step 4, going to locate another 2 points, or another point at least. And the last step, that is step 5, we are going to reflect and connect to get the quadratic curve. That's the last step. So the 5 steps are here. Step 1, we are going to find the axis of symmetry or the line of symmetry, which is step 1. Step 2, going to find the vertex of the curve, quadratic curve. Step 3, going to find the y-intercept of the curve. Then step 4, we locate another point and then reflect and connect the curve. So please follow. Task. We are given a quadratic function. Y equal to 3x squared minus 6x plus 1 is a quadratic function. This quadratic function we are going to draw using the steps that I've explained previously, step by step. Step 1, find the axis of symmetry. How do you find the axis of symmetry? Recall the formula that I gave before. The formula is x is equal to minus b all that over 2a. The general formula of a quadratic function is ax squared plus bx plus c equals to y. This is a quadratic function, the general formula of a quadratic, where a, b, and c are real numbers, and a must not be 0. If you get this, you get a quadratic function. And if you compare the graph given, the equation, the function given, and this, you will see similarities. The value for a there, our a is 3. The value for our b is negative 6. And that of c is 1. Positive 1 there. So to find the axis of symmetry, we're going to use this formula. That's the first step. And the formula is y is equals to minus b all that over 2a. This b is this linear term there. That's the b that we're looking for. Recall the formula. The formula is x is equal to minus b all that over 2a. This b that is here, this b is referred to the b value of the linear term of the quadratic function. And the a is the coefficient of the quadratic term. So whatever value that we have on this graph that is representing a, that's what we'll use as our a value here. And this is the function given. So we are going to take the values from this graph that is given. Y equals to 3x squared minus 6x plus 1. By looking at this, the values are given here. The a value for this graph here, from the general formula, is 3. B is equal to negative 6. So if you substitute this 3 in place of a in the equation given, and negative 6 in place of b in this equation, this is what it results to. x will be equals to minus, that's this negative that we have in front of b there, and the b value is minus 6, so in bracket, in parentheses, we put negative 6, all that over 2 in bracket, the value of a is 3, 2 times 3. So you can see here that x is equal to minus in bracket negative 6, all that over 2 times 3. 2 times 3 will give us 6. Negative times negative will give us 6 there. So it will be 6 divided by 6. 6 divided by 6 will get what? Will give us 1. This 1 there. Therefore, the axis of symmetry is x is equal to 1. If x is equal to 1, then you go to the graph. There's a graph given. And then we have our y values of the xy plane, and then the x values this way. So since a is the x value that we have there, x is equals to 1. So the x value for 1 here is this point. This is why the line of symmetry is drawn on this line here when x is equal to 1. So this is the line of symmetry or the axis of symmetry line. So that's the first step that we have to do. The first step, we have to draw the axis of symmetry. We move on to the next step. Step 2, the same function, y equals to 3x squared minus 6x plus 1. Step 2, we have to find the vertex. How do you find the vertex? Substitute the value that we get when we solve for x, that's minus b all that over 2a for x in the equation, and find y. That is the equation that is given to us, this equation here. That's our function, the function that is given. You will take the same function, y equals to 3x squared minus 6x plus 1. And the value that we get when we solve for the line axis of symmetry, we get, what did we get there? X is equal to 1 there. That's what we solve for. That value 1, you will substitute in place of x to get the vertex point. So when we substitute in place of x there, the unknowns, those are the x values there. X squared, we put 1 square. So we'll have 3 in bracket, 1 to the power 2. We have minus there, but we'll add, this negative will still come. Negative 6 in bracket, in place of x there, I'll put there 1, plus another 1 there. So we solve. 1 square is 1. 1 times 3 will give us back our 3. Negative 6 times 1 will give us negative 6, and then plus 1. So 3 minus 6 plus 1 will give us negative 2. So y is equal to negative 2. So the vertex, the point where the parabola will take a curve, will be when x is equal to 1 and y is equal to minus 2. On the x and y plane or Cartesian plane, and when x equals to 1, y equals to minus 2, x on the x-axis, x is equal to 1 at this point. And then on the y-axis, negative 2 is somewhere here. So we realize that they'll meet at this point. So the point here is the vertex. It means the graph will take a turn, bend, at this point. The reflection of the graph will be at this point there. Step 3. Step 3, we have to find the y-intercept of the same function. Y equals to 3x squared minus 6x plus 1. The y-intercept occurs when x is equal to 0. So substitute 0 for x in the equation, you will get the y-intercept. The same equation that is given, function that is y is equal to what? 3x squared minus 6x plus 1. I will substitute in place of x 0. So if you do that, you will get what? Y is equal to, in place of x there, I'll put that 0. In place of another x, 0. So when you substitute, you will get 0. 0 to the power 2 is still 0. 0 times 3 is 0. 6 minus 6 times 0 will be 0. So the answer y will be equals, because 0 minus 0 plus 1 is 1. So y is equal to 1. So y-intercept is equal to, when x is 0, y is 1. That is the point the graph will cut the y-axis. The graph cuts the y-axis at 0, coordinate point 0, 1. That is, on the y-axis at 1. That's where the graph will cut the y-axis. So if you understand very well, you realize that this one is the same one that we have here, positive 1. So the graph cuts at the y-axis on the constant term there. Because when x is 0, this will be 0. This value also will be 0. So you will get only 1. So that point on the Cartesian plane, when y equals to 1, is this point that is marked black there. Black paint there, color. So this point here is when y is equal to 0. So we need to indicate that point. So we solve for 3. So on the Cartesian plane, that is the xy plane, you realize that when y equals to 0, we can find it on the y-axis. Y equal to 0, we have to look at the y-axis. Y equals to 1 is at this point there. This point here is when y is equal to, y equals to 0 here, y equals to 1, y equals to 2, 3, 4, 5, 6, like that. So y equals to 1 at this point. Mark there. So we solve for the first step, we find what? The axis of symmetry, or the line of symmetry. Step 2, we solve for the vertex. That is this point there. Step 3, we find the y-intercept. So we are moving on. If we get to the step 4, step 5, then we'll connect, and then we'll get the graph. Step 4, plot an additional point. That is, we have to plot another point to help us get the curve on one side, so that we can connect, and then we get our graph. Choose an x value to substitute in the function. My advice to you is, because we solve for the vertex, and we also solve for the y-intercept, they are all on one side. It is advised that when you choose another point, you choose on the same side of the graph. So if we are going to choose another point, we can choose 1, negative 1, when x equals negative 1, negative 2, negative 3, negative 4, negative, so that we'll be able to get the 3 points that we need on one side. The point that I use here is using x equals to negative 1, and substituting in place of x negative 1, we'll get y equals to 3x squared minus 6x plus 1. So I'll substitute in place of x negative 1. So y will give us 3 in bracket negative 1 squared plus negative 6 in bracket negative 1 plus 1. Then you solve. Negative 1 squared will give us 1. Negative 1 times negative 1 is 1. 1 times 3 will be 3. Negative 6 times negative 1. Negative, negative, whenever we multiply, we get a positive value. So negative 6 times negative 1 will give us 6. So that's this plus 6, and then we add 1 plus 1. So y is equal to 3 plus 6 plus 1. 3 plus 6 is 9, plus 1 will give us 10. So y value at that point will be y equals to 10. So when x, the point that we choose, we have to choose, plot another additional point. The point that we picked, the first point, is when x equals to negative 1. When x is negative 1, y will give us 10 at negative 1. So we'll get the coordinate point that we need to plot. The point is negative 1 and 10. So we'll go back to the graph. That's the xy plane. X negative 1 is on the x-axis. We want to determine that on the x-axis. X is negative 1 at which point? At this point. On this line, x is negative 1. Y, 10. Y values are determined on the y-axis. We find the y values, they're all on the y-axis. So we have 0, 2, 4, 6, 8, 10 is at this point there. So where these two lines meet, that is the coordinate point there, and it's marked there. So this point there, this coordinate point is negative 2 and 10, just like the value that we get there. Sorry, negative 1 and 10. Negative 1 and 10. So now we are able to find the line of symmetry, the vertex, the y-intercept, and another point. So we have all three on one side. Step 5. Using the axis of symmetry, or the line of symmetry, reflect the points to get the other half of the parabola. We find the line of symmetry, that's the first step 1. Step 2, we solve for the vertex. Step 3, the y-intercept. And step 4, the extra point that we've solved for here. This step, we are to connect from the vertex. We're going to draw with a smooth curve with a pencil from this point here, that is 1 and -2, the coordinate point. We connect it with the y-intercept, then to the last point that we've solved. If you get this half, this line of symmetry is sort of a mirror image of the two halves. One side is solved. To get the other side, we are going to connect, that's what it says here, reflect the points to get the other halves of the parabola. Look at this point that we have here. That is the y-intercept. From the y-intercept to the line of symmetry, we have only 1 unit there. We are going to reflect on the other side of the line of symmetry. So from here to this point is 1 unit. We're going to do the same thing here and then mark this point, value there. And we are going to do the same thing for this point here, that is from -1 and 10. We reflect it on the other side. So this 2 units, we're going to take 2 units on the other side, so it will be 3 and -10 on the other side. So if you reflect those 2 points, then you connect the other half also with a smooth curve. That is from here, you use a pencil, you draw, connect to this point, and then to that side of the equation. Then if you do that, then you will get the parabola that we are looking for. This is the graph of the function y equals to 3x squared minus 6x plus 1. This is the way we connect the graph, and we get this. You might be surprised, you might be taught differently by using tables and values. What matters is at the end, you'll get the same graph. That's the most important thing. The method may differ, but at the end, the solution must be the same. And this is the graph of the function. We can see this is the line of symmetry that divides the parabola into 2 halves. The y-intercept, which is always the constant term there, should be on 1, which is also important. And then we have find another point, and then we connect all the 3 points together, so we get this point. So you can see here, x equals to 1 is the line of symmetry. So this is the way we draw the graph of a quadratic functions. So we'll look at another one, step by step. I want you to follow, so we understand step by step. Just like the way I solved this one, we'll solve that one together as well. Just like the way we solved the previous one, 5 steps, going to start with step 1. What is the axis of symmetry for the equation, for the function, quadratic function, y equals to x squared y is equal to x squared plus 2x minus 3. That's the function, the quadratic function there. Step 1, we have to find the axis of symmetry, or the line of symmetry. The line of symmetry, to solve for the line of symmetry, you have to be able to use the formula, and the formula, you recall the formula. The formula for the line of symmetry is, we're going to take x, because we solve for x, where the lines of symmetry, vertical line cuts the x-axis. X is equal to the formula, minus b, all that over 2a. What is our a value in this function there? Our a value, if you look at this function with the standard form of writing a quadratic equation, is in standard form already, which is y is equal to ax squared plus bx plus c. There is no value in front of the quadratic term. But in algebra, you should know if you have a variable on its own, the variable always have, all variables must have a coefficient. And the coefficient in front of this x here is 1. So a, therefore, is equal to 1. That's our A. B, the value for B is positive 2. So B is equals to 2. And those are the two variables that we need to substitute here in this equation to solve for our axis of symmetry or the line of symmetry. So therefore, this means if you substitute in, we'll have negative. Our B value is 2 there, 2, all that over 2 times an A there is 1. If you solve this out, simplify further, that will be negative 2 divided by 2 times 1, which is also 2. Negative 2 divided by 2, that will give us final answer, negative 1. So x, therefore, is equal to negative 1. That is the line of symmetry. So looking at this option, we'll see that the correct option, therefore, is option B. B there. B, x is equal to negative 1. So that's the first step. Step 1, we solve for the axis of symmetry. And axis of symmetry here is x equals to negative 1. Why is this important? Because this will help us. Let's say this is y-axis and our x-axis. We have values, let's say negative 1 here, negative 2, negative 3, and so on. The list goes. Then we have positive 1, positive 2, positive 3, 1, 2, 3 like that, negative 1, negative 2, negative 3. This value that we solve, that's the line of symmetry. X is equal to negative 1. X values are on the x-axis. Negative 1 on the x-axis is here. So all what you do is get a straight line, vertical line from the top with a graph, the ruler, you place a ruler, and then draw a vertical line that passes through this point, and that point, this, when x is equal to negative 1, will be our axis of symmetry. This will create the two images for the parabola, one to the left and the other to the right. Step 2, we have to find the vertex for the quadratic function. What is the vertex for y equals to x squared plus 2x minus 3? This is our second step. So we have to find the vertex. And remember, if you recall that we solved a similar one, to solve for the vertex, what do we need? You need to input in our line of axis of symmetry, the value that we get for the axis of symmetry, in the function that is given y equals to x squared plus 2x minus 3. The value that we generate, that will be the y value. That value will give us the coordinate that they are looking for here. The previous lesson we solved for x. There's a line of symmetry. Our line of symmetry was x is equal to negative 1. That is our line of symmetry. This value you will substitute in the function given. The function given is y is equal to x squared, quadratic term, plus 2x minus 3. If we substitute in place of x negative 1, we are going to get the y coordinate, the point that we are looking for. So now substitute y, therefore, is equal to, we substitute in place of x negative 1 squared plus 2 in bracket negative 1 times negative 1 minus 3. Negative 1 squared will give us positive 1. That will give us 1 there. 2 times -1, positive, negative, that will give us a negative value, so it will be -2. Then the last term, which is a constant term there, -3. If we add them together, we'll get the y-coordinate of the vertex. So therefore, the y-coordinate of the vertex, y is equal to 1 minus 2, which will give us -1, minus 3, that will be -4. So the coordinate for the axis of for the vertex will be the point we put in the x value first. And our x value is -1, comma, -4. This 2 point will be the point for the vertex. That's the coordinate point for the vertex. And by looking at these options that we have there, option A is the correct answer. Option A there we have -1 and -4. All other options there, but we have 1 for the x, which is completely wrong. The 1 for x, when we already solved for this one, x equals to -1. So the rest are all not correct. So we solve for the axis of symmetry and that of the vertex. So we are moving to the next step. Step 3, we have to find the y-intercept of the quadratic function. The y-intercept of the quadratic function, there's the function, the same function that we are using, y is equal to x squared plus 2x minus 3. The y-intercept of the function, we can find it by taking, at that point, y-intercept is when the x value is 0. When x is equal to 0, that will give us the y-intercept. So when x equals to 0, it means we'll substitute in place of x there, 0, whatever we get, that will be our y-intercept. So you realize that we have y is equal to, in place of x there, 0 squared plus 2 times 0 minus 3. This automatically will give us what? Y is equal to -3, because 0 squared is 0. 0 times any number is 0, so automatically we'll get -3. -3 will be our y-intercept. So the coordinate point for the y-intercept will be at the point when x is 0, y is -3. X 0, y -3. And the correct option there is option A there. X 0, y -3. That is our y-intercept. So if we solve for the y-intercept, then we move on to the next step. Now we'll graph the equation, the quadratic function itself. That is y equals to x squared plus 2x minus 3. These are the steps that I went through with you. Step 1, we solve for the axis of symmetry, where we get the x value equals to -1. Step 2, we find the vertex. You substitute the x value that you get in step 1 in the function in place of x to get -4. You get the coordinate of the vertex. The coordinate of the vertex is -1 for the x value and -4 for y. Step 3, that's the y-intercept. To get the y-intercept, you substitute, you take the value when x equal to 0 on this line, where x equal to 0 on this y value there, we'll get the x-intercept, sorry, y-intercept. So the function y equals x squared plus 2x minus 3. If you substitute in place of x 0, that will give us our y-intercept. So the y-intercept that we got was -3. Step 4, we find the extra 2 points. That is when x is 1, y is 0. When x is 1, you substitute 1 in, the y value that you get will be 0. When x is 2, y will be 5. If you can get that, that is the fourth step. The fifth step is to plot the points that you've solved for on one side of the parabola, of the line of symmetry. Then you reflect the final step, step 6, you reflect the points that you have on one side on the other side of the line of symmetry or the axis of symmetry. Through that, you will get everything. So let's follow. Step 1, the axis of symmetry. The axis of symmetry is when x equals -1. X is equal to -1. This is the x-axis at this point. This is why line is drawn, vertical line, the top down. This line divides the parabola into two halves, equal halves. Step 2, that is the vertex. The vertex is -1 and -4. -1 on the x-axis and -4 on the y-axis. Will meet at this point where it is colored red. This point there is the vertex. And at the vertex point is where the graph will take a bend on both sides of the line of symmetry. Step 3 is the y-intercept. Y-intercept is where the curve cuts the y-axis. Y-intercept, which is equal to -3, is where the parabola cuts the y-axis. -3, if you look at this, this is the y-axis, this line, vertical line. Where it cuts the y-axis is at this point. This point here is -3. So if you locate that point, then you need to locate another 2 points to complete the curve there. That is, when x equals to 1, if you substitute in place of x here, 1, y is equal to 1 squared, that will give us plus 2 times 1 minus 3. 1 square will be 1, so automatically we'll have 1 plus 2 times 1, 2 minus 3. 1 plus 2 will give us 3, 3 minus 3, automatically the y value therefore will be 0. This is why we have 1 when x is equal to 1, y is equal to y is equal to 0. 1 for x is here, y is 0 at this point. For that point also you need to locate it because it's very important. The other point is when x is equals to 2, y is equal to 5. The same procedure. Substitute in place of these x values, 2, you will generate an y value. That is, when x is equals to 2, our function that is given is y is equals to x squared plus 2x minus 3. That is the function given. So when x equals to 2, in place of x we replace with 2. So y will be equals to 2 squared plus 2 times 2 minus 3. 2 squared will give us 4. 2 times 2, the same 4 minus 3. If we add the 2, that will be 8. 8 minus 3 will give us positive 5. And at this point there. So we have when x is 2, y is 5. Let's look at the graph and identify these 2 points there. 1 on the x-axis, 0 on the y-axis. I've already marked that point. That is this point here. The next point is when x is 2, y is 5. On the x-axis 2, y is 5 on the y-axis. It will meet at this point there. So if we know the vertex, we also solve for the y-intercept, and then we locate the other 2 points, then automatically we get the 1/2 of the parabolic curve. That is, from this point you will connect with a pencil all the 3 points up, all the way up, like that. If you get the left-hand side, to get out of the right-hand side, to get out of the left-hand side, you need to reflect the points that we have on the right-hand side to the left-hand side. We have what here? 2 and 5. From this point to the line of symmetry is 3 units. That is from this point here, 2, 1, 0, and -1. We have 3 units here. You do the same thing, you reflect the same thing on the left-hand side. That is from here, you take 3 steps, 1, 2, 3 units. So you reflect and then you mark that point. You do the same thing at this point. When we have 2 units on this side, we reflect the same 2 units on the other side. Then we connect the points up to the other side. Then you get your full parabola, which is the graph of the function y is equal to x squared plus 2x minus 3. So this is the way you graph the function. This method might be slightly different from the way you are taught if you're in grade 11 or that of grade 12, because sometimes you'll be given table format. From the table, you'll find your y values and input in the table. But if you graph it, you'll get exactly the same thing like the one that I've solved in here. I've solved already. So it's very important you take note. It doesn't have to be the same method, but the solution has to be the same. That is important. Let's look at one and we try it together. Yes, practice. Graphed, a function is given. Y is equal to negative x squared minus 4x plus 5. If you look at this function, following the procedures that I've explained previously, step 1, we are going to find the axis of symmetry. The line of symmetry. And to solve for the line of symmetry, you need to remember the equation for the line of symmetry, which is x equals to minus b, all that over 2a, where the b is the linear term of the quadratic function and a is the coefficient of the quadratic term. So if you look at this, our b value will be negative 4. So b will be equal to negative 4. And our a value is the coefficient of the quadratic term, which is negative 1. That is minus there, but this negative there is represented. This coefficient, this variable there, have a coefficient in front of it, 1, negative 1. So the a value will be equal to negative 1. If I input in these two values in place of b and a, I will get the line of symmetry. So x, therefore, the line of symmetry, therefore, will be equal to x is equal to negative b in bracket negative 4, because b value there is minus 4. All that over 2 times minus 1. We simplify, we get your line of symmetry. So x is equal to negative is positive, 4 all that over negative 2, which automatically will give us minus 2. So our line of symmetry is negative 2 on the x-axis. Negative 2 on the x-axis, mark it together. Negative 2 on the x-axis is, when we substitute in negative 4 for b and that of negative 1 for a, the equation that we get there at the end is x equals to negative in bracket, b is negative 4. We substitute in bracket there negative 4, all that over 2 in bracket negative 1 in place of a there. If we continue to solve further, negative will give us positive. So get positive 4. 2 times negative 1 give us negative 2. 4 divided by negative 2 will give us our answer. Therefore, the x value we'll get there will be negative 2. That's our line of symmetry. X equals to negative 2 on the graph sheet. Cartesian plane there is at this point, here, where it is marked red. That is when x equals to negative 2. So what we'll do is we'll draw a vertical line at that point there, -2, when x equals to -2. To do that, represent it with this. That is our line of symmetry. So line of symmetry, x is equal to -2. Step 2, we have to solve for the vertex. The vertex is a coordinate point, x and y values. The x value of the vertex is the line of symmetry, which we have already solved. So the x value, x is equal to -2. That is the axis of symmetry. So we are going to substitute this -2 in the function given to get the y value. That will give us the vertex or the coordinate of the vertex. So the function is y is equal to -x squared minus 4x plus 5. The quadratic function that is given to us is y is equal to -x squared minus 4x plus 5. When x is equal to -2, we substitute in place of x -2 to get the y coordinate of the vertex. So the y coordinate of the vertex will be, y will be equals to, in place of x, I'll put there -2, -2 squared minus 4 in bracket -2, I'm just substituting, plus 5. -2 squared will give us what? Positive 4. So at the end we'll get the -4, because I have a negative outside. Minus 4 plus 4 will give us, minus 4 times -2 will give us positive 8 plus 5. -4 plus 8 will give us positive 4. Positive 4 plus 5 will give us 9. So the y value of the vertex, y will be equals to positive 9. So when x is -2, y is 9 is our vertex. So therefore, the vertex point, the point of the vertex is when x is -2, y is 9. So that is step 2. If we get the vertex, the next step is to find the y-intercept. That is where the parabola cuts the y-axis. And that is very easy to get. It's not difficult. That is step 3. The y-intercept. The y-intercept, the function given is y is equal to -x squared minus 4x, recall, plus 5. The y-intercept is where x is 0. When the value of x is 0, at that point, the equation, when x is 0, we'll get the y-intercept, where the equation cuts the y-axis. So y will be equals to 0 squared minus 4 times 0 plus 5. Automatically, these are all zeros. So the answer, therefore, will be equals to 5. So the y-intercept points will give us what? When x is 0, y is equal to 5. We are able to solve for the line of symmetry, the vertex, and that of the y-intercept. These 3 points, if you get it, then you solve for another 2 points. From there, then we will draw the curve and represent the graph. The other 2 points, will be, we have when x is 0, this point. Step 4, we have to find an extra 2 point that will help us to get 1/2 of the parabola. The 2 steps, that is the fourth step and that of the second step, you look at the line of symmetry and that of the vertex. Step 3, we solve for the y-intercept. So step 4, we have to look at another extra 2 points. So we'll pick points. Let's say when x is equal to 1, what will be our y value at that point? And when x equals to 2, what will be the y value at that point? Those 2 coordinate points will connect on the graph to complete the 1/2 of the symmetric parabola. So when x equals to 1, y is equal to negative, that's the function, x squared minus 4x plus 5. If we substitute in place of x there 1, we'll get our y values output. So y is equal to negative 1 squared minus 4, in bracket we are substituting 1 plus 5. 1 squared there is 1, so automatically we'll have negative 1 minus 4 plus 5. This will give us negative 1 minus 1 minus 4 will give us minus 5. So it will be negative 5 plus 5. Automatically, the y value, y is equal to 0 at that point. So the coordinate point for the extra first point there will be when x is 1, y is 0. It's very important. We choose another point, extra point. So when x is equals to 2, put this in the function, the same function. The function is quadratic function, y is equal to negative x squared minus 4x plus 5. When x is equal to 2, if I substitute in place of x there 2, we'll get y values, y output. That is negative 2 squared minus 4 in bracket negative 2 plus 5. Negative 2 square will be 4, so we have a negative in front of it, so it will be negative 4. Minus 4 times minus 2. We choose another point, that is when x is equals to 2, we substitute in place of x 2 in the quadratic function. So the quadratic function given is y is equal to negative x squared minus 4x plus 5. When x is 2, we substitute in place of x 2. This will give us negative 2 squared minus 4 times 2 plus 5. This 2 squared is 4. So negative 4 minus 8 plus 5. If we add together, negative 4, negative 8 is negative 12. Negative 12 plus 5 will give us negative 8. 12 plus 5 will give us negative 7. So the coordinate of these 2 points will be, the extra point will be when x is 2, y is negative 7. So we've solved all the way to virtual, all the way to step 4. We'll put these values in the graph. Then from there, we'll reflect these points to the other half of the parabola to get a complete parabola. That is the complete graph of the curve. So that's the graph. On the xy plane, we've already put substitute in place of x negative 2. That is our line of symmetry. Line of symmetry is already in. So we have to substitute in the vertex. The vertex points are when x is negative 2, y is equal to 2, negative 2 and 9 on the graph sheet. -2 and 9. 9 on the y-axis. 9 will be somewhere here, between 8 and 10. This -2 and that of 9, this point here, they'll meet at this point. This coordinate point will be -2 and 9. This will be our vertex, so we'll reflect at this point on both sides of the line of symmetry. Step 3, the y-intercept. The y-intercept is when x is 0, y is 5. So if you go back to the graph, 0, 5, the coordinate point 0, 5, when x is 0 on this line. Y is equal to 5. X is 0, y is 5. That is at this point there. This coordinate point is x is 0, y is 5, between 4 and 6. So we're able to get the vertex, the y-intercept. So we have to find the extra 2 points to complete the curve. So when we choose x equals to 1, we get an output of y value 0. So when x is 1, y is 0. So at that point, coordinate point 1, 0, x is 1 here, y is 0. So it's at this point. That is the first point. And the last but not the least is when x is 2, the output y is equal to -7. So 2 and -7 will be the last point to plot on the graph sheet. When x is 2, y is -7. 2 and -7, coordinate point C. So we are able to get all the 3 points on one side of the line of symmetry. All what we will do now, we'll reflect these 3 points on the opposite sides, because this will create a mirror image on both sides. That is the line of symmetry. It divides the parabola into 2 equal halves. This side, the opposite of that, will be from this point to 0, 5, we have 2 units. That is from -2 to 0 there. So we'll do the same thing on the opposite side. That is from here to this is 2 units, and we'll take opposite 2 units. So we'll mark that point. From the line of symmetry to this given point there, that is coordinate 0 and 1. 1 and 0. We have 3 units. 1, 2, 3 units. We'll do the same thing on the opposite sides. 1, 2, 3 units. So we'll mark a reflect point there. Then the last one will be from this point to 2 there, we have 4 units. 1, 2, 3, 4. We do the same thing on the opposite sides. 1, 2, 3, 4. So we've got all the points virtually that we need. All what we need now is to get the curve, that is the parabolic curve. Since we are able to find all the points that we need, now what is left is to connect all the points to get the parabola that we need. That is the quadratic curve. So to do that, we'll pick a pen and then connect all the points that we've solved for. So to do that, I'll start from here and then move up all the way to the vertex, then down. Make sure you touch all the points with the smooth curve, like that. It's not perfect, but in your graph sheet, it should be better than this. So this is the parabolic curve that we have drawn from the equation, from the quadratic function that is given. It will give us this output. This will be the graph of the function y is equal to -x squared minus 4x plus 5. Okay, the last part, which is to graph a function, which is y is equal to 3x squared minus 7. This one, you have to try it at home. It's an assignment for you. Try and solve this. In my next lesson, I will try and solve this with you. From there, then we move to the next lesson, which is solving quadratic equation by graphing. That's the end of the lesson. Until we meet next, again, I would like you to stay at home. The advice is always follow the instruction that the health officers are given. Wash your hands regularly and stay at home. You'll be safe until this problem all ends. Thank you all for your kind attention.